Hi, my name is Pranjal and I'm pursuing my final year from Maharaja Surajmal Institute of Technology in Electronics and Communication.
Hello everyone, myself Rohit Rajnish, a final year student in Electronics and Communication Engineering of Bhagwan Parshuram Institute for Technology. Simultaneously, I am doing my physical design domain internship from Pine Training Academy.
Now I would like to call Rohit for the presentation.
Okay, so today our project is STALYTICS. Like you have already studied in Tempus and Innovus, like STALYTICS is a bash project we have worked upon. Like it's your timing report intelligence engine. So what is STALYTICS? Firstly, we will get introduced by the R tool. Like STALYTICS is a powerful, user-friendly command line interface tool designed to analyze and decode complex timing reports generated by industry-based tools like Tempus or Innovus. So moving on to the problem statement that we are having, like that the timing reports are very time consuming, like reviewing 50 to 100 plus paths every run eats up our very much time, and there are many errors in the timing reports we have to work upon, and it is also unscalable to like study thousands and 2000 paths at a very low time. So we are working upon that problem statements in this project. Like, so what is the impact of the problem on the work we are doing? Like there are no easy way to compare the worst negative slack and total negative slacks and other components of timing designs, like we are going to study a bit later in our presentation. Like if it is very difficult to identify the critical paths quickly in the design, and even worse, engineers often have to repeat the entire process to analyze the hold and setup times in the design. And our objective, our tool is like quickly visualize all timing paths, like all the paths, like path 1, part 2, and like in numerous paths we have like thousands or 2000 paths we are going to analyze. And secondly, it is an interactive CLI based analysis, so we are getting a very user friendly CLI, so a user can very easily interact with the system. And we are also providing us the option from worst case scenarios in the design, so that we can work upon the design more efficiently. And we are also extracting the critical metrics that are used to extract the important informations of the design. And secondly, are the tool advantages, like what we are providing to the user. Like in Tempest reports there are many timing metrics like setup, arrival, required time, phase shift, and many more, like slack and delay. So but some there are very there are very pros, but there are also cons in the design. Like what it lacks, like skew visibility across launch and capture domains, and path prioritization via WNS and TNS, but we are working upon in a more forward in the design in future purposes. So firstly, we are getting to know about, like our tool is divided into three parts, like setup time tool, hold tool, and cell delay tool. Firstly, we are going to know more about the setup tool we have made. So firstly, setup tool, like it is setup tool, like it suggests, like it is working on the setup time. So timing closure is one of the most time consuming steps in the design to work upon, and the setup tool solve the automating the timing process by automating the setup reports in the design. It is just quickly analyzing the setup paths in the design, extracting the key matrices, and identifying the worst case paths in the design, so that the user can be more friendly to the design, that on which path they have to implement or make the design more efficient. And these are this is the, like you can see, this is our home page for the setup tool. Like here you can see different switches, like you can get specific the all details of a specific path, and but also a specific detail for all paths also we are going to show you in the demonstration also. And thirdly, the WNS and TNS summary of the design of the whole all paths in the design, also a help manual. And we can also we are providing a user friendly way to also provide a choice to the user to provide to always allow the user to give a file input to the design. And lastly, exit button to easily exit the tool. Like secondly, we have our whole tool. It is just similarly working like setup tool. It is just analyzing the whole timing reports. It is just quickly analyzing whole paths. The essential metrics are studied and identified the worst case violations in the design. This is the main page for the whole tool, and these are the same buttons we are already discussed in the setup tool. Thirdly and lastly, our main one of the crucial tool like delay tool. Here we are analyzing the delays in total path and giving the user the most critical cells, or the or you can say like inverter or buffers to be worked upon, like to make the setup and hold timing fixed. So this is the main page for the setup and hold delay tool manual. So here we are having, like, if we were to work upon the setup analysis reports or hold analysis reports. Thirdly, we have also a manual in the design, and you can see like there is also a STLX main menu. Like if we are already having a optimization analysis, we are, if in this option we are working upon in future purposes, and this is the second option, like cell delay extraction, we have worked upon. So it shows like, or if we are giving a path, it shows all the buffers, inverters, or any component or gates used in the design, and it will show is average time taken, and on this basis of average time it will be decided like it should be upsized or downsized in the design, and it will provide us the reports in the directories. So we can see like it will provide .rpt files in the system, where we can simply see like how the files are saved, and on which inverters or buffer the upsizing or downsizing should be done. So moreover, our project is mostly like command based, so it will be more understandable to you if there will be demonstration for the project. So I like to invite my colleague Pranjal to show you the demonstration.
Hi, so let's dive into the demonstration of our STLytics tool. So from anywhere you can type STLytics. I am typing it from the documents part. So this is our the interface of our tool, which is STLytics. As my colleague Rohit has shown you the manual, the setup timing, and the whole timing report analysis, the delay part, and the user manual. So let's look up for the manual first, as I don't know about this tool. So this is the manual part, and here it is like ST is a terminal based, and there is a hold, setup, and cell delay and gate path analyzer here also. So in the setup path, these are all the things like setup, required time, arrival time, TCD, TLD, slack, phase shift, and uncertainty. These are the extractions that are being done, and we can view the individual path summary, all path data by metric, worth, slack, setup paths, and WNS and TNS summary. Files validation, which is needed, is that it should be a Tempus generated, and it should must contain a setup checks. It cannot happen like if I am giving it a hold check and it is doing a setup check on those hold checks. And same for the whole timing report analyzer, I have the same as the setup part and the same validation. And for the cell delay part is also all the same, per delay, per cell delay, average gate delay, maximum delay, which is generated by Tempus. And the output format is output report format is saved as cell delay path summary with the path number, with the timestamp, and the txt. So these are the common features in navigation, interactive prompts, and menus. Help, you can type anywhere and you can get to this menu if you get stuck in between the tool. So this is the directory layout where all the layouts of the reports will be generated, and this is the usage flow. Like firstly you have to launch the tool from the terminal, then choose input file for that, and select the analysis type like hold, setup, or cell delay, and then navigate through the menus like do you need a specific path, do you need do you need all the paths with the skew or TNS or WNS. So all these paths, all these reports are generated and saved here. So requirements is bash compatible shell, you should have the bash compatible shell. Tempest generated STA report should you have, and in the Linux terminal this works like best, so you should have that. And when I press Q, and I can get to the STLytics part. So this is the STLytics, and I am pressing it, and I am again getting back to the STLytics. And firstly we should select the setup part. So this is the setup part, and this is my setup tool, and it is the user interface. So now I have to get to the enter file name or the absolute path. So I get to choose the first option, and then I have to place the file name which needs to be generated. So I should here like give a file name, which have setup parts, and it is searching in the documents part is the file name. So these are the file names which are same and being saved in the documents part. So let's go with the second part. And now I have the setup timing paths. Like I want to go with a specific path. I want to go with the all paths WNS help manual or back to the file input. So let's go with the all paths. So here is all the paths. There are total and violated are 0, and all paths. Now I have to get to what I need to extract. Like firstly setup time. So these are the setup time which are of 50 paths which are being saved, and now I will save it. And this is the saved directory which is being saved on the desktop for that. And now I get back to the main menu, and now I can look back for the WNS and TNS summary. So go with the TNS summary, and there is no WNS. Worst negative path, worst negative slack in this path is 0, so total negative slack will never ever be saved here. So I don't want to save it, so I will type n and hold back to the setup part UI, and then I got to the all paths I get to. And the setup, there is menu like setup time, phase shift, uncertainty, arrival time, required time, slack, uh, capture delay, launch delay, skew time, and top critical paths. So let's go for the top critical paths. And now I want to look for the 15 critical paths in this path. So these are the 15 critical paths in this report which is being saved, and then I save it. This is the report. So these are the reports which are being saved, and as you can see, these are being saved here. And then getting back to it, setup parts. So this is the path of 12th in the setup report, and then getting back to the setup part, and I'm now exiting and getting into the hold part. Now getting to the hold timing reports, and here is the hold timing report, and then I have to give the name for that, which report I have to analyze. And now it is being searching like the setup part, where we have seen the setup reports are being checked. So here is the file, and I will go with the third file name. And now I have specific path, all paths, WNS and TNS summary, help manual, and back to the file input. Same as a setup part, but for the hold generated Tempus reports. So first option, we can extract a specific path, critical paths, help manual, or going back. So I will go with the A part, and here I can get 26th path. So this is a 26th report: skew time, hold time, uncertainty, TCD, TLD, phase shift, arrival time required, and slack. For the optimization of a specific path, we also need a skew, which is not being shown in the Tempus generated reports. So by using scripting, we have extracted the skew of a specific path by subtracting TCD by TLD and getting it like 4.402 is getting like TCD here is 4.402 and TLD is 0. So when we subtract 4.402 by launch delay, it will come to 4.402 plus. So it will help in the optimizations when we look in a specific path. If a positive skew is happening, then it will always violates a hold path. So I don't want to save it and getting back to the main menu. Now I will look for the WNS and TNS. Here the worst negative slack is minus 0.002, and the total negative slack is minus 0.02. As the WNS is minus only one value, so the total negative slack will be minus 0.002, and I don't want to save it, so I will type no. And now I will look for the manual part. So this is the manual part. If you get stuck with the hold part, if you get stuck with the setup part, you can always go for the manual. So there is a what this tool does. which allows specific path analysis, all path analysis, viewing top critical paths, WNS and TNS. You can also look for the skew part, which is not being shown in the Tempest generated file. How to use it? So usage will be same as we have looked earlier. Launch the tool. When prompted, enter a valid tar.pt or .report file, and then select for the one part of analysis, because you don't want to go for, if you want to specific path, you will not go for the all paths. So you can type manual help at any part, and this is the output directory structure where all the reports will be saved. So file validation is always the same. It will be Tempest generated, and saving the reports, you will be prompted, like if you want to save the file, you will prompt it to type yes, that is Y, or if you don't want to save it, is no for that. And key reminders is hold specific, the files should have the whole paths so that it can analyze whole paths. And for the setup analysis, use the dedicated setup part. And this is only a terminal or a CLI based environments of Linux. So only there this tool can be happen. So press Q and I am returning back to the tool. Now I will get to the crucial part of this tool, which is very exciting, and which is looking for the delay part of the perfect cells that we have to optimize. So I'm getting to the delay part. This is the delay tool, and this is its the UI. And now so now I have given it a report file. Now I will select what analysis type I want to go for. Is it setup, hold, show manual, or exit to the, so I have given it the hold report. So I will check with the setup part. So it is not a setup report, it is not a setup report, because I have provided a hold report and I am asking it to do setup analysis, which is not possible. So I will again give the file, and now I will ask for the hold part. Now I will get to the which analysis cell delay extraction I have to do. So I will go for this, and which path I need to analyze. Let's go with the 25th path. So this is the 25th path. As you can see, the average delay of it is given like 0.8718, and the maximum single gate delay is 2.64, and the maximum delay is buffer x16. So these are the delays which need to be upsized, which need to be downsized in order to increase the delay. As you can see, the lowest delay in is it is 0. Why not I am here getting 0 as a maximum single gate delay? So 0, if you downsize 0, it will never give any delay for the tool. So we have only maximum single gate delay which needs to be prompted. So these are the gates which need to be optimized. Now let's go for the analysis of this tool. So this is a path. In the starting of the path, I have the average combinational delay. I don't have to go for the command line and go for that. And then I have delays, and the delays of the specific cells. And in the last, I have total 59 cells in this path. So these are the cells which needs to be, and some paths are being highlighted, so which I can analyze. Now I can also go for the analyze another path menu, and here 24th path, and this is the 24th path with the timing report that is being saved in our STA reports, and its average delay is 0.2437, and this is the maximum single gate delay, and buffer x16 is the highest gate delay in this path, in this 24th path. So here the 24th path is being saved, and here is the average combinational delay, that is 0.214237 nanosecond, and it is being saved, and total number of cells in this path is 59. And now I'm getting back to the main menu. Now again I am going for the setup part, and this is my setup report. And this is again I am being prompted for setup or hold analysis. Now I will go with the setup analysis, and the cell delay extraction for that. And here are the input file available paths are 50, and the paths, these are the paths. So I will go with the 34th path. So now I will go to look for the fourth path. So you can hereby see average combinational delay, maximum single gate delay, gate with the maximum delay is inverter X4, and these are the delays that need to be uh, upsized so that the delay can be decreased. So these are the cells which need to be upsized. So this is a 34th report. So you can see a emoji of a fire is being replaced at the starting of the cell that need to be upsized. So a user can see what cell is in front of this cell and what cell is behind this cell, which is causing a delay in this path or at this row, at this cell. So average combinational delay of this path 34th is 0.37091 nanosecond, and these are the cells that need to be upsized, and there are total number of cells in this path is 56. And I can analyze another path, that is I will go for the 14th path, and hence I have this. The average combinational delay is 0.313056. NOR X2 is the highest gate delay with the maximum delay of 1.8690. So getting back to the STA reports, and I will look for the 14th path, and this is the 14th path. So you can see the fire emoji in front of the cells which need to be upsized, and I can see what reason it is causing the cell delay. So I can upsize it accordingly, because if you are going for the upsizing and downsizing, you cannot go for blindly the upsizing and downsizing. You have to firstly look for the for the specific path which is causing this delay. So I have to see which cell is in front of this cell and which is behind the cell. Again, it can be also a cause for the cell delay, so I need to upsize and downsize accordingly. Now getting back to the main menu. Now I am on the first UI of the STAlytics tool. So this concludes the demonstration of our STAlytics tool. So this concludes the demonstration and the presentation part of our STAlytics tool. We would like to thank Pine Academy and Weber sir for the cooperation, and the mentors for the cooperation of making this tool. And we would seriously like to thank our mentors and Pine Academy and Weber sir for this tool.